All right, we got Sami Davies, a research scientist with Relational AI, and I want to give you all the kudos for that incredible LinkedIn carousel around SIGMOD pods that has created some extraordinary engagement and awareness. So thank you, Sami, for being here and joining us for this conversation.
Yeah, thanks for having me. It was really fun going back and forth with you and an intern who was with us, Assam at the time.
Yeah,
With
shout out
several
Assam.
iterations. Yeah. Um, yeah, it was fun.
It was fun for me selfishly. I mean, I can't get enough of digging into the technical side and working with you on that because boy, were those 10 contributions and then some fascinating. So I wonder if, well, just to kick things off here, because I imagine a lot of folks that read that carousel and clicked on it a gazillion times. Again, shout out to you and Assam and the team, of course. But I imagine they would love to hear from you. You know, as a research scientist, you recently joined Relational AI. We're going to get to your background. Can't wait to hear about that too. But are there, three, five of those 10 that
hmm
especially kind of got your attention? And if so, why? And, just go anywhere you want to go with it?
Yeah. Um, so I'm coming from like a theory background, and so when I say theory, I mean like very theoretical. Like my PhD's in pure math.
Nice.
I've only been like in computer science departments the past like what 4 years or so. So for me, it's a lot of the more theoretical research that, we contributed to SIGMOD and PODS that stands out, but then also learning how that relates to our product and like the work that we do here. Like that connection is something that I've never been a part of before, and like I've never really understood so much of like how the theory can deeply connect to the practice. So maybe maybe the best example, or like, one example of this is we obviously have the paper about the programming language REL,
Yeah.
which was a part of the SIGMOD, yeah, industry track. So REL is the programming language that is a part of our relational knowledge graph management system.
Yep.
And so REL is what we use in-house. REL is built off of, like, as a base, another programming language called Datalog. And so Datalog is like a very popular, very well used programming language. It's really good at handling recursive queries. So Datalog is very strong at that. So REL, the programming language that we use, is built off of Datalog, but it also uses as an intermediate step this variant of Datalog that we call Datalogo. So Datalogo is this important intermediate programming language for REL. And data logo is an extension of REL, which means that it's richer. Like you can express like more interesting recursive computations in data logo. But the problem is, while data log is this language that's very well studied, and in particular, we know that programs written in data log will always converge with this like kind of natural way to like run the program. This is not true for data logo. So Datalogo being a richer language, some of the programs you write in it are not always going to converge. Or even if they do converge, it might be too expensive, like it might take too long. So how this all connects together is, so we have our programming language REL. REL is using Datalogo, but Datalogo programs might be very expensive to run. So while we have the paper at REL, or the paper on REL in SIGMOD, there's also this paper in PODS that is focusing on the like fast convergence of programs written in Datalogo. So this is a very, very theoretical paper. It's called Polynomial Time Convergence of the Iterative Evaluation of Datalogo Programs. It's
I love that
written.
name. That's why I smile every time. That one in particular. I'm like, well, that's a cool name.
It's this paper. So this is written by I think I have everyone on it. It's Hung, who's
Yep.
a researcher with us, and then these three members of our research faculty who are Ben Mosley, Sungjun Im, and Kirk Pruse. So they're at Carnegie Mellon, UC Santa Cruz, and Pitt. And these three guys. These are all guys like very much in my like research community. Like when we go to like very small workshops and conferences, like they're in my crew.
Nice.
And Hung has been friends with all of them for many, many years. So they've all been working together for a very long time. But anyway, I saw this paper that they had, and to me it felt very theoretical. And also just like I just didn't like it felt very theoretical and I didn't really understand like maybe why we care as much about these like why at relational AI do we care about this data logo programming language? It's like to me it feels pretty orthogonal to what we do when I was first reading it, but it's actually like so deeply connected to rel and so deeply connected to like all of like the technical innovation that we're doing. So like us understanding when data logo programs have fast convergence is us understanding when is rel like running quickly. So like
Uh,
deeply intertwined here.
I love that. I'm gonna probe a little bit, just as someone who is fascinated by this space, but not a obviously not a research scientist and not nearly as informed. So bear with me if this if any of my questions are, are not as
Well,
informed as
and
they.
bear with me if I said too much too quickly.
No,
It's
no, no,
just,
no,
yeah,
not at
yeah.
all, not at all. I one of the things I think is beyond interesting, and I haven't been to SIGMOD Pods, but one of the things I heard, besides the fact that it's in Berlin, which I love, one of my favorite cities, I heard about this notion that a lot of different types of people come together that come from really different backgrounds to attack and to discuss and collaborate around
Hmm.
solving problems with very different lenses, right? So you mentioned theory versus maybe some of the more commercial sides of the equation and whatnot. So I would love to hear from your background, what's it been like with a more theory based background joining relational AI and then looking through this multidimensional lens at these contributions to SIGMOD pods, because maybe it's a little bit of a different lens that you're around, being around multiple different stakeholders, including those that aren't even on the research team and or product and
Hmm.
engineering, those that are very much non-technical. So I'm just curious what that's been like for you.
For me, it's felt very dynamic, honestly. Like it feels really different. In so I'm a research scientist at UC Berkeley, and so what that means, like day to day, is I'm working with people at Berkeley who like do exactly what I do. Like we're very much in the same like subfield. We all use the same language. We kind of have similar tastes in terms of like the problems that we care about.
Hmm.
And so then coming to relational AI, it's so much broader. And with it being so much broader, like what that really means is there's so much more that you need to understand. Like you need to be fluent in so many different ways that people talk about problems now. And it's harder. Like it's way harder. It's so much easier to speak the language that like you've become an expert on the last whatever 10 years. And it's so much harder to have to like learn something that just feels totally different. Yeah, so for me, it's really cool to be able to see the connections between stuff that I would very much consider in my wheelhouse and then stuff that feels very out of my wheelhouse. Like programming, like I'm not a programming languages expert by any means. But it's very cool to see that, I am like an expert in like optimization research. And so to be able to see how optimization research is important for developing new programming languages is, I think it's just something I never thought I'd be doing. It's very different.
Well, it's a perfect segue right into your background. So give us the background. The PhD background, how you ended up joining relational AI, and just let's go through that. And big shout out to our friend Ibrahim. The 16 years in the making, joining relational AI, it worked with Molham. And I don't know if that has anything to do with your background as well, but I love hearing the backstory about, the background of all the different super talented folks at Relational AI, and
Yeah,
then ultimately
yeah.
how you ended up joining the team.
I Yeah, I'm under the impression that a lot of people join relational AI because of Moham, and I understand why. Like he's
It's
very
true.
he's a super clear vision, and I don't think I've ever met someone who's so capable of like he's plugged into everything that's going on while keeping depth with it, which is like extremely unusual. Um, but similarly, okay, so I've been familiar with relational AI for like several years now, mainly because these guys I mentioned on that one paper, Ben, Kirk, and Sungjin, they're like in my research community. Ben and I, in particular, have been working together for several years now. And so I've been working with him, and I knew that he was doing like, one day a week of his research was spent on work related to problems at relational AI. And so I was kind of in my frame of reference, but then about a year, no, 2 years ago, I was a part of this like research program that Ben and Kirk and Sungjin were, but then also that Hung and Mahmood were as well, who are researchers at Relational AI. And they're kind of just like they're a little bit of just like the stars on campus. Like everyone knows Hung and Mahmood.
Nice.
Yeah, like everyone really respected. There, I mean, there was a lot of other people there, but like they were the two guys that to me really stood out. They were very visible. Honestly, they're the nicest guys. Super social. They're both runners. Honestly, that's a big like Ben and I also run, so like there's some type of
There you
running
go. Running
connection there.
culture. There you go.
Yeah. Yeah, there's a photo of Mahmood, Hung, me, and my partner Max after we ran like the Berkeley half the year after we moved here.
Nice.
But I mean, honestly, in research, I feel like you're often just looking for people who you think might be nice to work with. It's actually a little bit less about the problems and more just about like, do these people seem nice and, do they seem to have good taste in problems? And sometimes that's more how you pick. You pick more the people you want to work with than the specific problems sometimes. So it was a little bit of that. I was just looking to diversify some of my research interests. And I knew that Ben, like a longtime collaborator of mine, had really enjoyed working with Hung. So I just reached out to Hung and I was like, will you take me on?
And
Yeah.
he's like, yeah, we can run together. We can work together. It'll be great.
We haven't been running, we have been working together, less running together now. But yeah, yeah, I think that's mostly it. My background is in something known as scheduling algorithms, which are like not, which are pretty orthogonal to what relational AI does, like very different really. So it was a bit of a, I don't want to say it's like a research jump, but it's trying something very different. This is stuff that's not really in my wheelhouse. So, but after getting to do so many, you're working on the same problems for so many years, sometimes it's fun just to switch things up.
Without a doubt. And I wonder, I think we had talked before jumping on the camera here and turning the camera on, just about some of the, kind of the nature of how relational AI balances giving researchers the freedom to pursue fundamental research while also, the commercial relevance and balancing
Hmm.
that, and, how research collaboration, works at relational AI compared to, more academic settings. I think it'd be interesting to hear your thoughts on that, given, your background.
Yeah. Um, and I was thinking earlier about, I'm actually like, how much relational AI's work, how much being a researcher here versus in industry, I think is one piece of it.
Yep.
Like, I'm thinking of other people I know who are working in industry research, and some of them are doing very cool work, but like respectfully, it's different. Like a lot of them are working on things that like I wouldn't necessarily want to work on. And there's many reasons for that. Often things just feel more clearly tied to like, I don't like just less freedom on what you want to work on. Whereas at relational AI, it's somehow this thing is happening where like as the team is developing our relational knowledge graph, questions just keep on coming up. So there's this cycle of like the product that's being built and then questions coming up that like maybe the engineering team doesn't know immediately how to solve. These aren't like quick engineering problems. These are actually like very deep research questions that, no one knows how to answer. And I think it's maybe because I think it's a little bit of like the startup culture. Like we're not Google, we're not, we're not some like existing product that's been around for a long time. Like we're doing something very fundamentally new. So new research questions are coming out of it, which, the research team and, scientists can work on. And then some of those insights get integrated back into the product, and then the cycle just repeats itself. But what I really don't understand is like why the questions coming out of it are so much more interesting than what's going on at other places. It's very confusing.
It seems quite clear that the intellectual curiosity that you have and the team has, it must be very exciting when these questions continue to come up, and some of them perhaps have been contemplated somewhat and others haven't. I guess one of the questions I would have in regards to that going back to the carousel just briefly,
Hmm.
we had 10 contributions that we profiled in there. And again, me not being on the research team and not being a research scientist and definitely not a PhD, there was some language in there just from a business perspective that I just found absolutely fascinating, as and code compression and taking,
Hmm.
just because I know what that can do to elevate logic out of existing code that can ultimately, operationalize ontologies and drive,
Hmm.
the knowledge graph promise that people are getting very excited about when the enterprise AI community. And so I guess that's a little bit of more of a kind of a commercial question for you, and you can kind of kick
Hmm.
it back to me and be like, but when you're out and about in the Berkeley area, if you're around your researchers and your community, or even just in Northern California, where there's so much going on within the AI community, are there any topics or trends that tie back to those 10 contributions that are especially interesting to you that you feel like they're emerging, and they might be tied to knowledge graphs, they might not? But I'm just curious because you're at the epicenter of everything out there, which I'm so jealous about. Even though we love North Carolina, we love where we are, but there's a lot going on out there. So just
No,
long-winded
I think
question.
that's
Yeah,
no, I think that's a good question, and I understand. I'm thinking
yeah. Think
like
away.
I'm going to answer your question a little bit differently with like what it made me think of.
Awesome.
Um, when I tell people about what I get to work on, like, and I mean people like out and about, like it's whatever. Like if you meet someone and they're like, "Oh, what do you do?" and you could talk about it for like more than 5 minutes, they are so jealous. They're so
Of
like
course they are.
they're
They're like, that's
so
so
jealous.
interesting. Yeah,
Yeah. And honestly, like, and why they're so jealous is like technical depth.
totally.
Like a lot of people, even people with PhDs or people who, are very technically knowledgeable, it's really easy to wind up in positions in industry where honestly what you're doing is very shallow. And so for anyone who's a little bit more like mathematically curious or who's like done some like deep math before, they are so jealous that like I get to work somewhere where I actually get to do like deep math still. Like I get to do like I literally I had like dinner with like an old friend over in like Dolores Park the other day. We just like got burritos and we're hanging out in the park. And he works at like a big tech company now, still ostensibly as like a research scientist. But, he was like asking me about the problems I get to work on. And he like texted me after and he was like, I'm so glad that, that you still get to do like deep theory work. Because I think we are living in a time where, there's so much happening with LLMs. There's so much like there's so much hype,
Yeah.
and that hype can lead to like more shallowness in research as we're like exploring new ideas. That's just how it is. When new things come up, it's going to be shallow for a while because you're just starting to dive in. So, and on like that's the thing that's really sticking out to me. The things on the carousel is there's so much depth in here. There's so much depth about programming languages, about optimization, about like database theory, and this really differentiates us from like what's going on in other like industry research teams.
Yeah, I couldn't agree with you more on that. And I think if you could maybe speak to that a little bit more in terms
Hmm.
of kind of, let's say, more shallow versus more depth, how would you kind of describe the difference between those two, and maybe throw out an example of a type of problem that you get really excited about solving that has
Yeah,
that
yeah,
depth, you know?
yeah. I think so. There were several papers featured in the carousel about cardinality estimation.
Hmm.
And so cardinality estimation is like the most important problem in query optimization. So we're basically trying to use statistics about a database in order to estimate the output size of a query.
Hmm.
And by estimating this output size accurately, you can then like create query plans for like actually evaluating that query. And like this can be hugely expensive if you have the wrong estimate on that output size.
Yep.
So these estimates are super important for like developing query plans. So this is like a very long-standing problem in database theory research and practice, actually, like just super important problem. And like, we have several papers that are addressing this in this year's SIGMOD and PODS. This is like the work that I'm doing for relational AI right now is on cardinality estimation. So it's just super fundamental, and it's so cool that like in an industry position you're still doing like this very fundamental research to database theory. And so we both have like there's a paper in actually was it SIGMOD or PODS? It must be SIGMOD. Yeah, it's like it's the like there's a SIGMOD best paper award to this paper that's on LP bound, which is like a new type of
Hmm.
cardinality estimation. And there's both like theoretical and like practical guarantees for LP bound. And so it's this estimator that like not only do they, like write these, awesome results about, but it's actually very, very similar to how we handle cardinality estimation at relational AI. So it's not like exactly the same thing, but like the insights there between like what's exposed in this paper and like what we're doing are actually super similar. So like that's super deep. And there's also this more theoretical paper on cardinality estimation, which is more similar to like the line of work that I'm doing, which is like it's examining cardinality estimation more from like a computational hardness perspective.
Mm.
So like it's treating it like it's a really hard problem, and it's asking like, okay, given that this is a really hard problem, when can you still do cardinality estimation efficiently? So like we know we might not be able to do it all the time, but we're asking like, okay, but in practice, when can we actually do it efficiently still?
Yeah, fascinating. And I'll go with one more question, being cognizant
Hmm.
of time. I think that this conversation is definitely going to get a lot of people excited about wanting to join relational AI, right? Because of all the things that we're talking about here. So I wonder if you could share a bit more about, what you find so exciting about the folks that you get to work with, and how you mentioned stretching, right? Which is always cool
Hmm.
too. So anything else you want to share, Simi, about just the nature of working with such extraordinary talent and people, and just relational AI in general?
Yeah. I've talked with so many people since I've been here about I actually think I think I'm a decent technical communicator, but having to work with people who are a little bit, they're like some people are in my field, some people are more outside, some people are really outside, like non-technical or experts in some other type of technical field or just non-technical entirely, like learning how to communicate with them, like why your research is cool. I actually think that's like so important. And that's something that just like having like a breadth of people at relational AI has exposed me to more. And it's exciting. It's exciting to get people interested in the thing that you're interested about.
Such a perfect answer. And Sammy, appreciate it so much. It like I said, I think there's a lot of people that are going to watch this that are going to go back into the carousel with an even more enthusiasm to dig into what you described. But I also think that you've done a fantastic job translating, which I've seen firsthand as we were working together on this stuff. And I think it's really cool because it is so complex for those of us that aren't necessarily on the research team. And you do such an extraordinary job at taking the really complex and translating it, which obviously demonstrates the grasp that you have of the subject. So thanks again so much for joining us. I know everyone's going to really enjoy this one.
Thanks for having me. Yeah, I appreciate it.
You bet. We'll see you next time.
Yep.
Thank you.